So today we will be discussing about what do we understand by centroid and center of gravity. I hope all of you, might be having an idea regarding centroid and center of gravity, as you must have gone through in your previous classes also. Now, before we can go into the actual problem solving situations here with regard to the mechanics, we will get a brief idea again. What does this mean? Firstly, as you already know, can anybody tell me what is center of gravity? Anybody center of gravity? Anybody center of gravity? Okay. Here, what we actually are concerned with regard to understanding the center of gravity is that we all know that any body, whatsoever it is, they are basically composed of number of different particles, and those particles have different masses. Right. For example, if uh, we have a body, and we know that this body is composed of infinite number of particles. Right. It has infinite number of particles, and they can vary in their masses, they can vary in their sizes. So now we also know that the this body, when it is located within the gravitational field. Now if it is in the gravitational field, what happens if any body is in any gravitational field? And we know that the body is composed of number of infinite number of particles. Right. For example, let's say those particles have some weight. Right. They have some weight. Those infinite number of particles have weight. If we say the total weight of the whole body is W, right? Now the uh, different particles that are there on this body will be having dw. Dw, let's say dw1, or dw is enough, dw, and summation of all these dw's will give you what we say the total weight will be equal to integral of dw. Right. We say the total weight will be integral of dw, because it is summation of all the weights of the particle. And now that these particles are the total weight of the body, it will be attracted towards the gravitational pull, right? Because there is a field, gravitational field, by which from which we actually calculate the weight of the body. If this particle has a mass m, now what will be the weight? If mass is m, weight will be simply mass times g. Weight will be simply mass times g, and it is being attracted towards the Earth's center. Right? Every particle of this body now is being attracted towards the Earth, towards its center, towards its center. Now Now the force of attraction, which is basically proportional to what? It is simply proportional to mass of the particle. It is proportional to mass of particle. Therefore, we can simply say it is being the mass is being pulled downwards, and that mass, when it is pulled downwards due to the gravitational pull of the earth, that is known as weight of the body. That is known as weight of body. Mass, when it is attracted downwards towards the gravitational pull and having the gravity g, then it is called as weight of the body. Okay, and we see that all these particles, they form to be a parallel force, parallel system of forces towards gravitational pull. They are all parallel towards downwards, right? Because why downwards? Because of gravitational forces form to be a parallel forces. Now, this is actually now the point. For example, here we have discussed that we have number of particles and each particle will be attracted towards the center, right? Now, if we will see what will be the resultant of all these particles, we actually see what will be the resultant of all such parallel forces, which are there due to different particles when being attracted towards the gravitational field. Then this point through which the whole weight W of the body acts, right? For example, if we had dw was differential element weight. Now when I take the resultant, for example, here now my resultant is, let's say this is my resultant now, which is w, which is w resultant of all the particle weight. It is resultant of all the parallel forces which is due to the particle weight, irrespective of its position. We don't consider what is the position, where are the forces, where is this force. We don't look, we check the magnitude of all the forces irrespective of checking the position, and that is known as the point at where you are actually calculating your center of this resultant force is called as center of gravity. It is actually the resultant of all the forces being applied towards the gravitational pull. Now you can also say the weights that were actually formed, which have formed a parallel force system, right? Here we have a parallel force system. It is actually the total weight of the body which passes through a single point, and that single point is this. That single point is this. We have mentioned that point somewhere here, and we say that point is supposed to be the center of the gravity. Now, how is it different from centroid? What does centroid and center of gravity mean? Are they same or they are equal? Now, it depends. They are actually in some cases same or they can be different as well. It primarily depends upon the type of the body. Which type of body are you discussing about, or what parameter of the body are you discussing about? Centroid, when you are basically discussing about plane figures, which include triangles, right? Which include triangle, which include circle, etc., wherein you are basically discussing areas. When we have a circle, what are we concerned about? We are concerned about its area, maybe its parameter, right? We are not discussing about its weight. Or we have a circle. When we talk about circle, it means that we are concerned about area. There we don't have any mass, right? We're not discussing about masses. And centroid is said to be for those plane figures. Okay, we call center of gravity as centroid plane figures. Okay, and now how can we actually calculate this center of gravity and centroid? What are the various methods by which we actually calculate centroid and center of gravity? We have primarily two types of methods by which we actually calculate what centroid or center of gravity. Firstly, we have by geometrical consideration. Secondly, we have by moment. First one was geometrical consideration, and second one was by movement method, or you can say by movement method. Now, firstly, we'll discuss about geometrical considerations, wherein you can calculate what your centroids or center of gravity. Right. Now, firstly, if we have a simple uniform rod, how can we calculate its center of gravity? We have a simple rod and we want to know the center of gravity. You need, if it has a length, you need not to do much. You can simply say at the middle point, it will be having center of gravity. Wherein this will be L by 2, this will be L by 2. That means this will be, let's denote this center of gravity by G. It will be at middle point. Simple, uniform rod. Secondly, if we have a rectangle, if we have a simple rectangle, these are geometrical considerations where you need not calculate where is the center of gravity or center. In rectangle, let's say this is your rectangle, right? It has length L and it has height H, right? And you can simply say at a distance of L by 2 from this point, that is somewhere here, L by 2, and at a distance of H by 2, which is H by 2, and at the point where they meet, here is your G. H at H by 2 and L by 2. Simple. At the center of that, you will be having your centroid or center of gravity. Okay, now if we have a simple triangle, let's firstly say we have a equilibrium triangle, and then we want to calculate the center of gravity. Simply, the center of gravity will be where the medians meet. This is the point where the medians are meeting, and you can easily say this point is your G, where the medians meet, right? Now we can have different types of triangles. For example, here we have now let's say we have one more triangle, which is a right angle triangle. We have right angle triangle, and what about that? Where can be the medium be held? Where can be the medium be? Now let's say it has some dimensions. Let's give them a name: A, B, and C. Now if we want to understand how can we calculate the medians, having let's say it has base is denoted by B, and height is denoted by H, and we want to know where is the median. Simply we want to know where is G, right? Now from the similar triangles, we can simply say where can be the median. Let's draw a mm, don't touch the screen. You might have already, let me grab this first. We have this right angle triangle. Here we say uh, 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 in order to calculate centroid or centroid, let's say and A, H, and C. That means these two triangles, this triangle and this triangle, right? These two triangles, we can say GE by HC. GE this and HC. HC is the bottom one. They are equal to AGE, this one, and AH. They are equilateral. Sorry, it's a right angle triangle. So you need to understand they are actually equal to 2 by 3. Therefore, you can say your GE is equal to, or X bar is equal to 2 by 3 of HC. And HC is how much? 2 by 3 HC is your B by 2. So you can say it is cancel out B by 3. Therefore, you can say centroid is at B by 3 from C, and it will be, if this is to B by 3 from this point, B by 3 from this point, therefore you can say from this very point, B point, it will be twice B by 3. It will be 2 by 3B from and B. Okay? It will be B by 3 twice B by 3. Therefore, you can simply say when you have a right angle triangle, centroid will be from this very point, it will be, let's say centroid is at this point, from this point it is 2 by 3 of B, and from this very point it will be B by 3. This is with regard to right angle triangle. Now, if we have, okay, fine. One more centroid of trapezium. Center of gravity of trapezium. Okay, before centroid of trapezium, I would also like to tell you one more type of triangle. Let's say we have any sort of triangle wherein we don't know whether it is a equilateral triangle or we have a right angle triangle. In such cases, how will you calculate your center of gravity? Let's say this is point A, this is point B, and this is point C. In order to calculate what? Center of gravity of any triangle, wherein we don't know the all the dimensions of the triangle. So let's say we have these dimensions given, which is height is your h, okay, and there is a distance that has been given. Let's say that distance is a, it has been given, and we have another distance b that is given, and the total length is L. Now you want to know what can be the where can be the center of gravity of such triangle. As you already know here, your total length is actually divided into A plus B. Right. Now you want to know what is the center of gravity of the triangle at the horizontal distance x from B. Right. We're actually checking from B. Center of distance, you need to understand here, whenever you are about to calculate the center of gravity, you need to make a reference axis or reference point from where you are actually checking the centroid of gravity. Let's say our centroid of gravity is x bar from B. Now you have to calculate the moment of inertia. How will you calculate the moment of inertia here? Does anybody have any guess to calculate the moment of inertia? Okay, fine. Here I will do it myself. You can do other few examples yourself. What we do here is we actually try to get the center of gravity or centroid by moments. By moments. Now, how does that happen? We will say, let's say this is your 1, this is your 2. We will say summation of moments of area 1 and 2. If we sum the moment of area of 1 and 2, that should be equal to what? Moment of area of A, B, and C. Simple. That should be equal to the moment of area of the total triangle. We have divided these two triangles into two, and we say summing the moment of these triangles, that is sum or moment of triangle ABD, right? AB, this point is your D, plus triangle ADC about B. You should mention that about B. That is equal to moment of area A, B, and C. Right, that is the total triangle A, B, and C. I have divided into two, ABD and ADC. I say the moment should be equal in order to calculate my center of gravity. Firstly, in order to calculate my center of gravity from point B, B is your reference point. What will be the moment of triangle ABD? The moment of triangle will be simple. Lower diagram, area of lower diagram, how much is your lower diagram? It is simply half of base. How much is base? A into altitude, and that is H. This is area of lower diagram multiplied by its lever arm. Now what will be its lever arm? Its lever arm will be simply, now this is your right angle triangle. You have two right angle triangles, and you have already discussed where can be the centroid of these right angle triangles. Now you have area. This is your area of lower diagram multiplied by, this is what are we calculating? We are calculating movement. Keep that in mind. We are calculating movement. Movement will be what? Load into lever arm, load into distance. Now what will be the distance? Distance will be simply from this very point. Distance of the centroid will be of this triangle will be 2 by 3 of A. It will be 2 by 3 of A. If it would have been from the point D, then it would have been 1 by 3 of A. Now it is from the point B, therefore you can say it is 2 by 3 of A plus area of movement of area 2. Now what is area 2? Lower diagram, that is again half of base. How much is the B into altitude? That is again H multiplied by the distance. Now distance will be from B. Now here your distance will be 1 is this A, right? And plus you will have to see where will be the centroid of in this distance. It will be A plus from this it will be B by 3. It will be B by 3. So you can say A plus B by 3 will be the distance. It will be the distance. Now this will be equal to what? Moment of the total area. Now what will be the moment of total area? That will be 1 by 2 half of base L into altitude X, right, multiplied by the centroidal distance. How much is that? That is X bar, which we have to calculate. We want to calculate the centroidal distance of the total area, that is A, B, and C. Right, now we have divided into two right angle triangles in order to calculate our centroid of gravity of any triangle. Now
Excuse
solving
me,
it.
sir.
Yes.
Could you please explain how did we take that A plus B by 3?
Okay, fine. I will do that. Listen, now in triangle A, D, and C. We had two triangles. One was A, B, and D. A, B, and D was this. A, B, and D. What was your load? How much was your? We want to calculate the moment. Moment of what? Moment of a load diagram. Load was half a base into altitude, simple triangle, and we wanted to know what will be the lever arm. For example, in this triangle, A, B, and D, we want to see where is the centroid, right? And we have calculated. We simply want to know what will be the movement about B. If you have this load diagram, this was your load diagram, and we wanted to calculate the movement about P. Simple. We had area half a base into altitude, and we want to see lever arm. Where will it act? Where will it act on this particular triangular load form? It will simply act as we have already discussed. When you have this right angle triangle, centroid will be somewhere here. Centroid will be somewhere here. It will be, let's say it is here, and it will be 2 by 3 of, let's say this is L, 2 by 3 of L. This portion will be 2 by 3 of L, and this will be 1 by 3 of L. Total will be, if you will add 2 by 3 and 1 by 3, it will be equal to L. Every right angle triangle will have its center of gravity from the left end. From the left end, it will be at a distance of 2 by 3 L from point B here in this case, and it will be at a point of 1 by 3 from L. Okay, this was your condition number 1, ABD. Now if you have ABC, now ABC was, this was our triangle, this was our complete triangle. We are calculating, see what I have written here, X bar from B. That means our reference point is B. We are checking our center of gravity from B. So here in this case, we want to calculate now movement of load form 2, right? From B. From B. Now, as you already know, in this triangle, we have again half a base into altitude will be the area of the load diagram multiplied by centroidal distance from B. Centroidal distance from B means from this is your point B. Firstly, this will be as it is. This is A, which you have already given. And from A, we are actually checking which area. We are checking area A, D, and C. ADC is now, if it is A, complete lever arm is your A, and then you have to check where can the center of gravity act. It will act from this point. It will be at a distance of B is the total length, if you can see, of this right angle triangle. It will be multiplied by 1 by 3. That means B by 3. And this portion will be 2 times B by 3. This portion will be 2 times D by 3, and this portion will be B by 3. Now you cannot write only B by 3, because you are actually checking movement from B. Therefore, this A will get added up. I hope it's clear now, Zarka.
So it is clear now.
Okay. Now, when you solve this, and you have to calculate what? X bar. X bar is what? It is the center of gravity from B. X bar is center of gravity from B. And X bar comes out to be L plus A by 3. Please solve it at your own places. We don't have that much time to solve it. You can do it yourself. X bar will be L plus A divided by 3. This is your centroid from B. Okay. Now, if you wanted to calculate your centroid from C, moment of center of gravity or centroid by simple geometrical interpretation. Now we were discussing regarding a center of gravity of any triangle, which can be divided into two right angle triangles, and we calculated where can be the center of gravity, and we saw from point B in previous diagram. We saw from point B our center of gravity will be L plus A divided by 3, right? And if we want to calculate our x bar from, let's say, C, it will be simply what? It will be L plus B by 3. If you can yourself do some homework, you can see how can that happen actually. Now we have many other geometrical shapes wherein we can actually check the different center of gravities of different plane frames, plane figures. We were talking about trapezium. We talked about trapezium. So here, if we have a simple trapezium and we want to know where can be the center of gravity, let's say it has sides. We have two parallel sides, A and B, and it has a height h, and it's actually measured from this axis. It's measured from, let's name this as A, B, C, and D. We are actually measuring it from side B. This is your side B. As if it is symmetrical on both the sides, let's say it's symmetrical, therefore you can simply say that at the center of A and at the center of B, the center of gravity will be somewhere on this line, right? It will be somewhere on this line, right? Now where can it be? That depends upon your height, which has been from where the center of gravity is to be actually calculated. While we have to calculate it again, if we want to do it, I can show you again, but I want you to do it yourself. I will give you a hint how you will actually calculate your center of gravity for this trapezium, right? If you will see A, B, C, D, let's name the A, B, C, D, E, F. Again, as I have already told you how to calculate your center of gravity by simple summation of moments. You will sum up the moments, right? Now, C and D. Now, the moments will be the movement of trapezium, whole trapezium, that is A, B, C, and D. Let's say about CD. About CD, please have a look that this time I'm not checking in vertical direction, I am checking it from horizontal direction. This will be simply equal to, it will be movement of triangle A B A C E, right? A C E, and it will be again plus movement of triangle B F and D. That means this one, B F and D, and it will be movement of a rectangle A B E. And summing up the movements about CD. Now, if you will solve it, you will get the centroid distance from. So that is your homework. Please do it yourself. Solve it, movement for different triangles, sum them up, and then tell me what will be your centroid. Now here it is not from the x-axis, it is from y-axis because we have calculated it about CD. CD is in this direction. That means you will get your moment of inertia in y-axis. That will be equal to, here in this case, it will be equal to h by 3 times b plus twice a divided by b plus a. That means from CD. That means from CD you can write y bar is somewhere here. This is the distance. हाँ, तो here your center of gravity is, as you have calculated, it is h by 3 b plus twice a divided by b plus a. That means it is at this point, which was at the center, and this distance is your y bar. This is your centroid of gravity. Center of gravity or centroid. This was with regard to what? Centroid of a trapezium. Now, can anybody tell me what will be the centroid of any semicircle? Centroid of semicircle. If this is your semicircle, centroid is from this base, it is 4r by 3 pi. Again, from y-axis, you can see centroid is 4r by 3 pi. This is for semicircle.
तो ये कैसे
Then
आया?
you have, I cannot show you all of them. You have to do it yourself. Again, I have already when you we talk about parabola, we have maybe you need not to for this semicircle it will be tedious, but this is an assignment for you, not right now. I will give you this in assignment, but after few classes, because you will get to know how actually this happens. Here again, you can say you can calculate movement of this area, you can calculate movement of this area, and for that you need to see what will be the centroid of a parabola. There is a process by which you can calculate the centroid of the parabola. Just wait for some few more classes, then you will get to understand it. And as of now, just write down all these geometrical interpretation of centroid, and try to solve whichever you can, and rest let it be there. We will do it later on. And then we have a few more. For example, we have a cube. If we have a simple cube, can anybody tell me where can be the centroid of any cube? It will be simply at a distance of, because cube will have all the dimensions same. That means, for example, if we have L, if we have L as the dimension, L will be same for all the sides. Therefore, you can say your G will be at a distance of L by 2. L by 2 from this, if this is also L by 2, it will be somewhere here, but at a distance of L by 2. Here you can say, but it will be from every face. It will be from every face, right? Now, if you have sphere, again, it will be, your center of gravity will be again from, it will be d by 2. Center of gravity of sphere will be from d by 2 from every point again. Right. If you have hemisphere, it will be at a distance of 3r by 8 from its base. From its base. Okay. Right circular solid cone. H by 4 from the base. Okay, again, your centroid will be at a distance of, but it's right circular solid cone. It will be at a distance of h by 4 from, you need to understand the reference point here is again in the y direction. That means it will be y bar, h by 4 from base. Okay, these were some of the geometrical figures or shapes where we can actually calculate the center of gravity by simple method of geometrical interpretation. But we can also do them by actually by movements. right? As you had already seen, I had calculated one of the what we called as centroid by simply applying the moments formula, and we calculated it. Similarly, we can do it for hair also. When we are not known what can be the geometrical center of gravity, we can easily do it for simple figures. But when we have complex figures, for example, as you said, regarding semicircle or hemisphere. In such cases, what we do without going into the calculation of geometry, we simply do it by movements. Movement is the best possible method by which we can actually calculate the center of gravity. Now, what does this method of movement say? What is it all about? You might have already discussed various things with regard to calculating of movements by the method of movement. For example, let's take we have a body. For example, we have a body, and we say that it has a number of particles. It has particles here. It has particles here. Finally, we want to know what will be the center of gravity. Center of gravity basically will depend firstly upon what? The total mass, if we are talking about mass, or it can be on total area, right? It can be weight, mass is weight actually. It can be with regard to weight, it can be with regard to area, it can be with regard to volume, and so on and so forth, wherein we actually calculate where can be the centroid of the resultant forces, parallel forces, resultant because we will be having parallel forces towards the center of the gravity, and we will calculate what will be the resultant of all these parallel forces. Let's say that resultant is here. This is the resultant of all these smaller particle forces, or this is the mass, or this is the area, or this is the volume. Then we want to know where does it act with regard to the reference point. Now reference point can be either it can be from the y-axis, or it can be also from the z-axis, or it can be also reference point can also be from x-axis, y-axis, and z-axis. Can also incorporate one more axis. Let's say we have this way. when we uh, when we have been asked to calculate the centroid of gravity from all the three axes, please do not touch the screen. Let's say this is our y-axis, this is our x-axis, this is our z-axis, and we have been asked to calculate the centroid of movement of from all the axes. Now, as we had discussed earlier also, that what does this centroid of gravity mean? It basically means the centroid of a gravity of a body is basically that point through which the resultant of the system of the parallel forces formed by the weight of all the particles. Right? Here we are talking about weight formed by the weight of all the particles of the body possess. Right, and given from the reference point, we can calculate the total weight of that body with reference to the centroid of the gravity. For example, here we are discussing, let's say we have different masses. Let's say this is M1, this is M2, and M3, and so on and so forth. And when we talk about weight, therefore we have to see if M1 is mass, what will be the weight? It will be M1G, right? It will be weight will be M2G, and if this is the total mass, M weight will be M times G, right? And then we will be having different set of centroidal distances. For example, for particle m1. This is our, this is, let's say if you are talking about only x-axis and y-axis. If we are talking about only x-axis and y-axis, this is our x-axis and this is our y-axis, then the distance from this y will be, let's say it is x1, and m2 is at a distance of x2, and m3 is similarly at distance of x3. And ultimately what we want distance of the resultant weight, which is x bar. Let's say that is x bar. Now when we are saying that from at different points of these masses we have different centroidal distance, and in order to calculate only one centroidal distance for the whole resultant masses or the weight, we can simply say by the principle of moments, right? We are using the principle of moments. We can simply say, again using the principle of moments here, which I have already used in showing you how to calculate the centroidal distance of various plane figures like triangle and right angle triangle and so on and so forth. uh, you will, if you have to calculate it by the principle of moments, you will simply say the total mass times what, centroidal distance, that will be equal to m1 x1 plus m2 x2 and so on and so forth. And in order to calculate your centroidal distance, it will be simply equal to summation of masses into distances, particular distances of particular mass divided by the total mass. This will be your centroidal distance of that particular body. And again, you know the total mass will be equal to m1 plus m2 plus m3 and so on. It is the total mass. And again, the reference point is axis of reference that we are actually talking about. Axis of reference will define whether you are calculating x bar or you are calculating y bar. If you are calculating your x bar and if you are calculating your y bar will basically depend upon your axis of reference. Axis of reference of any plane figure is generally, it is basically the, usually what we take, it is the lowest line, or you can call it the lowest line. Here at this very point this is the lowest, and on y-axis this is the lowest axis point, right? Now you can again say in this way, if you have to calculate various okay, fine. If we have to see now that we want to see what happens actually with the with all three axes, that is x, y, and z axes, how can we calculate it? Again, here, as we already know, if here, if we will say that the total weight, if we will discuss about weight, the total weight that was given here, this is the resultant, and these individual particle weights can be represented as, let's say, dw. If individual are dw, we can simply say when we are talking about weight, we can say our w is equal to integral of dw, right? Our total weight is summation of all the particle forces weight, right? And we are talking about what, we want to know what will be our centroid of gravity with respect to x, with respect to y, and with respect to z, right? Let's say here, let's say this is our y bar, this is our x bar, and this is our z bar. We want to know in all three axes where is the centroid of gravity. We want to know in x, we want to know in y, we want to know in z. Now, for example, if we have to calculate what actually happens, uh, but again here you have to see, okay, x bar, when we are talking about in x direction, x bar multiplied by the total weight will be actually what? It will be simply integral of x times dw. It will be simple integral because we will have to integrate it through all the number of particles, right? So then you can simply say, when we are talking about x direction, it will be equal to x bar is equal to integral of x dw divided by, as we know that w is equal to integral of dw, integral of dw. This is with regard to x bar. And if we are talking about y bar, bar will be again equal to integral of integ integral of y dw divided by integral of dw. This will be in y-axis, and if in z-axis, it will be again integral of z dw divided by integral of dw. This will be in your z direction. Simple. There is nothing much which needs to be explained here. Now we can have also a few more things. This was with regard to weight, right? Now what will happen if we are talking about masses? Again, the weight will be replaced by masses. G will be equal for every volume, every weight, and you can simply say it will be same for example, here your x bar will be, if you are talking about only mass, then it will be equal to x dm divided by integral of dm, right? And y bar will be integral of y dm divided by integral of dm, and your z will be integral of z dm divided by integral of dm. This is when we talk about masses, when we talk about mass or any body. Here this is primarily done for dynamic response, or we can say accelerated motion of body, right? This was with regard to mass. Now if we will talk about volume, as we already know, here mass is actually what? Mass is when we are talking about volume, that means we are taking what we called as density into consideration, because density will be constant for the masses. So here you can say x bar will be again equal to x dv volume divided by integral of dv, and y bar will be again y dv divided by integral of dv, and again z bar will be equal to integral of z dv divided by integral of dv. This is with regard to the centroid of a volume. And about area, I have already discussed. Area will be simple. This is for volume V, V, and V. When we are talking about area, it will be integral of x dA divided by integral of dA. This is area A. And this will be integral area y d divided integral of dA. And
तो आपकी
for
वॉइस बफर हो रही है, हम कुछ भी नहीं
z
तो
it will be
Excuse me, sir.
तो हम नहीं सुन रहे हैं कुछ भी।
integral
Excuse me, sir. We cannot hear anything. Sir,
z d a. Anybody, Zarka, are you able to hear me?
sir,
जैसे
now
अभी
we are able to hear you. We couldn't hear you, and I guess you couldn't hear us at all.
Yeah, now it's okay. I'm able to hear you now. So, what was the issue?
So we didn't hear anything. Area wale part se you were saying हमने कुछ नहीं सुना.
From where did you was my voice broken?
Area जब आप बोल रहे थे area वाला, उसके बाद we couldn't hear और
We
screen
discussed
freeze
about
हो गई.
volume. Did you
हाँ,
hear that
volume.
much about volume?
Yes, sir, we
जैसा
did
वॉल्यूम
hear.
हो गया था, एरिया
Huh,
का मैं
after that, I discussed about area again, same similar procedure, and then I discussed about line, wherein I probably was talking about those lines which are not straight. If we don't have straight lines, if we have curved at some point, or there's in circular half semicircular type, in such cases also, if you want to calculate the centroid of gravity or the centroid, the procedure will be same. Now we will get an hands-on experience by actually solving these problems, which we will do in our next class. Is my voice okay with you, or it's still buffering?
Also, it's okay.
Okay, Sahil, are you there?
Yes, sir.
Okay, we'll wind up the class today because some network issue has arisen. We'll continue it in our next class.
Yes, sir. Okay. It's already.
Okay, okay.